Today's experiment is pretty much just heating water and boiling it. And what I did already was I gave you a preview of what that experiment looks like. I decided to show you how it's done if you have a stove top, because it's going to provide more heat than the alcohol burner, although you can do the alcohol burner as well. Let's go to the module page. Here in the announcement, as you guys can see, is the video link that I place of experiment number 8. And then I also put in here a revised PowerPoint showing you the procedure that you guys are going to be doing. So let me just do that real quick so that you guys can see that PowerPoint. When you click on that link, it'll actually not show it on your browser. You're going to have to download it because it's a PowerPoint slide. Once you click on this, then it'll download it to your computer. And then what you will need to do is open it up, and then it'll automatically play like that. And what you want to do, because it's a slide, is just hit your arrow forward and backwards, and that will show you the way I would usually give you that I would present the PowerPoint if you were in my class. So let me go ahead and do that. Okay, I think so. Hitting the arrows for this, let me print that. This right here is just the objective of the experiment. You guys are given a bunch of unknown. You're going to be graded based on the accuracy of your results, depending on the unknown that you have. There's A, B, C, and D. What you guys are going to be doing is you're going to be calculating the concentration, more specifically the mass percent. Your next experiment, the titration of vinegar, you guys are not only going to calculate a mass percent, but also a molarity. So this particular lab will actually help you in terms of giving you practice for that calculation. What you guys are going to be doing ultimately is calculating the concentration of your salt solution. And when you do all 3 trials, they all should be similar to each other. Okay, so this is how you would calculate it based on mass percent. And that's what you guys are doing, is you're doing mass percent. You're going to have the mass of the residue, which is your solute, divided by the mass of the solution, which is your well, that's your solution. Okay, so mass percent is the weight of the solute divided by the weight of the solution times 100. When you do that, that's a percent. When you multiply by 100, that percent is also parts per 100. Parts per 100, and we talked about this in my lecture, is a part per 100 100 parts. So if there's a sale 50% off, it means that you save 50 cents for every dollar that you spend. 100 cents, 50 of that cents is 50% off. So when you calculate a percent concentration, it's that part of the solute in the solution. So if it's 25% solution, then 100 parts of the solution, 25 of that is the solute. Okay, so again, that's percent, and you guys are going to be calculating that. There's also another concentration that you guys will be calculating, and that's fairly easy to do. Okay, instead of multiplying by 100, what you guys are going to be doing is you're going to be multiplying by 1,000,000. Okay, you guys are going to be multiplying by 1,000,000, and that unit is just called ppm, parts per million. So you see in this slide right here that on the turquoise here, you have the weight of solute divided by the weight of solution times 100. Well, parts per million is just the weight of the solute divided by the weight of the solution, because that's what you guys are going to be doing. You're going to be doing the weight of the solute divided by the weight of solution times 1,000,000. Okay, 10 to the 6. And when you have that number in your calculation, then you want to put ppm. If you take the weight of the solute and divide it by the weight of the solution and multiply it by 1,000,000,000, then that's parts per billion. Okay, that's parts per billion. And that's what you see here in this particular slide. It's just a multiplier that gives you ppm or ppb. So it's nothing new, and you guys shouldn't be intimidating by that type of unit. The reason why we use ppm and ppb is because when the concentration is so low and you have many numbers for your percent, like 0.00012%, then a lot of people would just dismiss it and say that that's practically nothing, when indeed it could be important if it's a contaminant or it's a poison. So that's why we quote things in ppm or ppb if we need that concentration to be recognized. Okay, so just remember that. So this is your procedure. What you guys are going to have is you guys are going to have 3 vials. You want to find these vials in your plastic bag, and hopefully none of it spilled. And it's going to say experiment, salt solution, unknown A, B, or C. They should all be identical. They should not be different. The reason why they're identical is because they're going to be the same solution, and you're going to repeat it 3 times. These 3 vials, they're all going to be the same. You guys are going to have a alcohol burner, a evaporating dish, a wire gauze, a beaker. You want to have some water, wash bottle, probably put some deionized water. You guys are going to have a scale, okay? And you can see that at the bottom in the right corner. That's typical equipment that you guys are going to have from your KLM Bioscientific. This is the procedure. You guys are going to make sure the evaporating dish is clean and dry. And you're going to do this one at a time since you only have one evaporating dish, okay? You guys are going to make sure it's clean and dry. You're going to turn on your scale. You're going to tare it. And then you guys are going to weigh your evaporating dish. While the evaporating dish is on the scale, make sure the scale doesn't turn off. You're going to take one of your vials and pour the liquid to the evaporating dish. This will change the mass. So now you have the evaporating dish mass, and you have the evaporating dish plus the solution. What you want to do next is you want to take that evaporating dish and either place it on top of the mesh above the alcohol burner, or if you have a stove, put the wire mesh over the element and then put a beaker with water. It's got to have water, and then put the evaporating dish on top, just like experiment number 4. Okay, in experiment number 4, you guys had some 3 items on the bottom, and you had ice on the evaporating dish, and then you sublime one of the chemicals. This is similar, but now you've got salt solution in that evaporating dish. What you can do now is heat it up the evaporating dish directly if you have an alcohol burner, or you start boiling the water. And you'll see that in the video. When all the liquid in the evaporating dish has evaporated and all you have is solid residue, heat it up some more, okay? Because there are still residual liquid there. So heat it up an additional 3-4 minutes until it's nothing more than solid, and then turn off the flame, allow it to cool. It's not really going to cool that much. After 10 minutes, go ahead and remove it and set it in your counter and allow it to cool some more. It's got to be room temperature. Make sure there's no residual water on the side or in the bottom. If you need to, wipe it dry. And then what you want to do is, when it's at room temperature, turn on your scale, tare it, and then weigh the evaporating dish and the salt residue. And that's the experiment. You do that for trial 2 and trial 3. Okay, and then this is the data. This data just describe what the salt solution looks like. Hopefully there's no contaminants in it. The approximate volume is not critical. It's probably about 3 to 4 milliliters, 5 milliliters. You're never going to use that calculation, but it's good to make that observation. This is where you put the mass of the evaporating dish for your 3 trials. So here's a sample calculation. For my experiment, my mass was 94.997 for the first trial, 125.645 for the second, 96.626 for the third. I used 3 different evaporating dish, in other words. Then the evaporating dish plus the solution is more than that, 105.002, 135.607, 106.511. Again, these are just sample data. After I evaporate the liquid, what I have left is the salt residue, okay? And that salt residue should be more, that combined should be more than the evaporating dish. If it's less, you've made a mistake. It should be more than the evaporating dish. This one is 95.074. And then these are the other 2. You're doing this 3 times, in other words, okay? Then what you want to do is a calculation. The mass of the residue is just going to be 4 minus 2 in this table. The mass of the evaporating dish and the residue minus the evaporating dish. So that difference is just 0.077 for my calculation. You can do that for the others. The mass of the solution. Well, the mass of the solution is just 3 minus 2. The mass of the solution in evaporating dish minus the evaporating dish. You got to subtract off the evaporating dish when you do these calculations. So that's what I have right here, 10.005, 9.620, 9.885. Now I can calculate the percent concentration. That's just the mass of the residue, which is your salt, divided by the mass of the solution. So when I do that, 0.077 divided by 10.005 times 100, I get 0.770%. The others are close, and then the last one's really messed up. Okay, I can do the average where I add the 3 and divide by 3. That's the average. Or I can throw out the last one because it's an outlier. It's really off. Okay, and then when you do the ppm, all you've got to do is take 0.077 divided by 10.005 times a million or times a billion, and that'll get you these numbers. It's going to be bigger than the percent, but that's okay. And then parts per billion will also be a big number, but I want you to practice that. And that basically is your lab. Okay, that like I said, this lab is not difficult. You've got a bunch of post-lab questions here asking you about what the residue and what common ions might be there. And then this particular question right here asks you, how would your results be influenced if some of the water splattered or some contaminant came in, or just different scenarios? Okay, so you guys can think about the experiment and think about how will the percent concentration be affected. Will it be higher than the true, lower than the true, or there should be no change? So that is your experiment. Let me just move on and go through the video so you guys can see. And what I will do is I will probably scrub it through so that it's fast, but because I don't want to watch the whole video, and you guys can do the same thing. So again, okay, here it is, very top level. That's the first link. Let me show you where that is. So for this experiment, experiment number 8, you want to go right here. Okay. So this is another video that you can use to try. It tries to explain solutions, but let's go to this one. So here I just show you what your vials are and how to turn on your scale. Okay, And here I'm just showing you how to weigh your evaporating dish and then pour your solution directly after you weigh your evaporating dish. Okay. Then I'm showing you that the evaporating dish goes on top of the beaker. The beaker has to have water. Here I'm using my stove top. If you have a new wire mesh, it's going to crackle and these things are going to fly off. Don't worry, that's just some residue. And then what I've done in the video is I've fast forward these things so that you don't have to wait 20 minutes for these things to boil. So if you just let it play in real time in the video, it actually is going 20 times the normal speed. Okay. So I'm just taking the video and speeding it up as I edit it. And you can, of course, scrub through and get to the point that is important. So I'm just allowing it to cool. And you can see the salt residue right there. And I'm talking in the background. And then once I'm ready and everything's set and cool, then all I've got to do is weigh it. That will be recorded in your data sheet. And then you want to wash it and then repeat the whole process again. Notice there's some liquid water here, and that's because I didn't dry the evaporating dish in the bottom, so my results are going to be off. Don't do that, okay? Make sure it's completely dry. And then I use the hair dryer to make sure the thing is dry. If you're going to use the hair dryer to remove any residual water, don't point it directly at the residue because it'll blow it out. You got to be gentle with it. If you blow it out, then you'll lose some residue and then you make a mistake. So the rest of this video is just showing you trial 2 and trial 3. So I'm showing you all the trial and I'm fast forwarding it here. Okay. And that pretty much is the experiment. Eight, you should have 3 salt solution, unknown A, B, or C. Please record that. So for experiment 8, you should have 3 solutions and it should say salt solution, unknown, and in this particular case, it's unknown C. They should all be identical because you're going to repeat this experiment 3 times. So I have unknown C. You guys could have A, B, C, or D. Make sure you record that. First thing you want to do is get your scale, turn it on. This is your evaporating dish. What you want to do is you want to weigh your evaporating dish. So right now, the scale reads 0. I'm just going to put my evaporating dish there, and it gives me a mass. In this particular case, 52.71 grams. So I'm going to record that, and then I'm going to take one of my solution. This will be number 1, and then I'm just going to add this to my evaporating dish. So my initial mass is 52.71. When I add this, and you want to add all the content, make sure your evaporating dish is clean. I'm going to record the new mass with the solution, in this particular case 56.82 grams. So that's The difference will be the mass of the solution. The next thing I'm going to do is I'm going to take my beaker of water and I'm just going to put my evaporating dish on top of my beaker of water, and then I'm going to boil the water. And you could use your alcohol burner, or in my case, I'm going to use my stove top. And then I'm going to turn on the burner. And I want to turn on the burner in such a way that you want to be careful about heating the wire mesh. It's going to initially just spark until it's conditioned. And then we're going to put the evaporating dish and the beaker on top, like that. And we want to adjust the flame so there's a gentle boil. After 4 or 5 minutes, and it looks like the residue has no more residual water, go ahead and turn off your stove and allow the evaporating dish to cool. This will take approximately 10 minutes. After approximately 10 minutes, you should be able to hold the evaporating dish and then just set it aside. And again, allow it to cool. Okay, the beaker will have some steam coming off, so just leave that alone. The residue with the salt remaining will just be allowed to cool. In the meantime, to prepare for the second trial, what you can do is add more water to the beaker. So while that is just sitting on your stovetop, go ahead and just allow the evaporating dish to cool. The next procedure is to weigh the evaporating dish with the residue. When the evaporating dish is cool, go ahead and turn on your scale. Make sure to tare it so it reads 0. And then place your evaporating dish and the residue and weigh the total mass. In this case, it was 52.93. Once you have the mass, then you are ready to do the second trial. What you need to do is clean the evaporating dish. The residue here is just plain salt, table salt. So you can go ahead and dump it in the sink with water. So I'm going to clean the evaporating dish and then dry it. To ensure that the evaporating dish is totally dry, I'm just going to take a hair dryer and make sure that the evaporating dish is totally dry. I'll allow the evaporating dish to cool again. Give it a couple of minutes. Then I want to make sure that I turn on the scale, tare it, weigh the evaporating dish, the mass should be the same as your first trial. In this case, it was, for my experiment, it was 52.71 grams. And that was the mass of the evaporating dish empty on the first trial. Next, I'm going to do the experiment again, this time with the vial that I just labeled 2. That way I don't mix it up. Okay, this will be trial 2. It's the same unknown. It should give me the same result. And I have my mass on my scale, and then I'm just going to add the salt solution. And when I add the salt solution, I'm going to add all the salt solution to the evaporating dish. And that'll be the mass of the solution. So this mass comes out to 56.95. Next, I'm going to take the evaporating dish with the salt solution and place it over my beaker of water again, and then repeat the experiment. So I'm just going to turn this on and then allow the boiling water to evaporate the salt solution.